Good morning and afternoon, everybody. Welcome to our weekly Wednesday Autodesk HSM, our technical webinar. Today we're going to talk about our fast track to CNC programming. Those of you who are new to using our integrated CAM and you're new to Autodesk, we have a fast track program which I highly recommend that you join, especially when you're new to our interface working with CAM. So if you join, get on these webinars. You'll see what's up and coming. You'll see our schedule. We have seminars going across the U.S. And the main purpose of these fast track webinars, seminars, and classes that we're doing is to help new users to be able to get from that idea, that napkin sketch, or that drawing, or what you're getting from your customers, to be able to use our integrated CAM to be able to get that code to your machine to have a part in your hand. That step. So we do have classes going across the U.S. this year. Keep an eye out. Again, if you join in, you'll see what that schedule looks like and where those classes will be. We also do our weekly webinars. These Wednesday webinars are really for the new users to get you up to speed on what our interface looks like and how easy it is to use. So you'll have access to all of our webinars and our recordings of our previous ones, as well as Pluralsight training. I highly recommend. Our expert users, our resellers, we have a lot of great people who have been working with the software since it began with HSM Works. The elite users are putting together a lot of their own classes, their own webinars, and their own seminars and recorded videos where you can get access to, as well as classroom information, download parts, work with those parts directly as you walk through step by step. I highly recommended the Pluralsight training. So as you start to download, as you've gotten here, you've downloaded a trial, started to work with our interface, saw how easy it is to use, whether you're working for Inventor, which is Inventor HSM, or if you downloaded HSM Works for SolidWorks, or even working with the CAM inside of Fusion 360. So that's your starting point. So starting to work with it, to get your own parts in there, start to draw up your own parts and get CAM working, 2D, 3D, multi-axis CAM. And again, I recommend signing up for our Pluralsight. It all leads up to Autodesk University. November, I believe it's the 14th through 16th at the Venetian this year. Autodesk University is where it all comes together. All the classrooms that you see, all these webinars that we do. On the Fridays, you see the elite users who come in and give us some great webinars. It all adds up. They will all join us at Autodesk University. It's a huge team where you'll have seminars and webinars and classes, and it all comes together with actually running those machines. This year we had John Saunders with us working with Tormach, bringing people who have never run a machine before, program, go over to the machine, and actually had a part in their hand at the end of that, or a few hours that it took. But John was there on hand, and a lot of the elite users were with him to help those classes. So I highly recommend signing up and joining us at AU. So that's our fast track program. This webinar is part of that, and you'll start to see as you join up a lot more access, a lot more information at your fingertips. So, okay, so for today, what are we going to cover? I'm going to walk through Fusion. We're going to walk through a basic interface of how you can access your data and your projects no matter what computer you log on. So we're going to walk through A360. We're going to look at some hubs in the projects that you may belong to, and you can share data and also work with other data no matter where you're at. We're going to draw up a part, a basic part. It's going to be a adapter plate for a manifold and a carburetor. So it's just going to be very basic. We're going to draw one up and model it directly right here. We're going to import a Kurt vise, which is a SolidWorks part. We're going to import it into Fusion, make an assembly out of it so we have a moving jaw and have joints where we can put our part into. And that'll become our assembly template. And then we're going to apply some 2D and 3D toolpaths to make that part. Post-process, get the code out, which is what this is really about, is getting that good code to your machine so that you can run the parts that you had put toolpaths on. And then we're going to make some design changes, some simple design changes, but to show you how that integration works between the CAD and the CAM side. This is the part, just a real basic part, an adapter plate we're going to make, starting from scratch. And we're going to download and upload our Kurt vise and make an assembly out of it that we can use to match what's on our machine. With that, let's get started. I'm going to go into my interface for my web here, just Google Chrome. And you can go through Firefox, you can go through your IE, whatever browser you have. So when you log into any computer, you can log into your hub. So when you start working with Fusion, you get a hub to start out with, and you can share your projects and start working with your projects that way. So I'm going to log into my A360, my hub. So you'll get a link to your hub, and you log in. Right now, I was in earlier, so I didn't have to log in with my username and password. But if the first time I'm using it, it'll come up with a box where you put in your username and password for your Autodesk account. And when you get in, you see a view that looks like this in my browser. I can see some activity that's going on in my projects that I have access to. I have other users who have access, and we have shared access to different things in our projects here. And I can see that activity that's going on. Also, these are my projects that I'm working with, and I can see all the projects that are only owned by me, shared with me from other people, and also archive projects in the past. I can pin some. We can put a pin on here, so we want to see those all the time when we log in. In fact, we're going to work with this project right here. As I go into it, you see there's not really much here. I have a work holding folder where I uploaded the Kurt Weiss just in case, as we're walking through, I'm not able to get it uploaded, but we will. We'll take a look at that. And so I have other projects that I'm working here. Now, we also have hubs that we work with as well. So other teams and other companies will invite you into their hub, which means it's their projects and their internal access to the data. So I could switch over to my Autodesk team, our team Autodesk for CAM. And I switch in here, and this is where we have resources that we share for doing training. So I have these different projects where I can change whether I want to see the tiled or not. I can go into our technical training files. I do this when we do training. And we share these files. Like here's a 2D training files that we use, the CAM Mania part. I'm going to switch over, and I can see some icons of what it looks like. I can also see over here other people who have access. There's Adam, there's Al, a lot of other people who have access to our CAM training who use them, update, and we share data. And we can see what access they have, who's the administrator, who's the editor, and you have access to do this for your projects as well. I'd like to see, let's say, this overview for this. This is our CAM Intro to Machining. This is what we use for training. So I can see this. I can see what parts are in it, where they're used, if there's any drawings. I also see the history of what's going on with that assembly, and also any comments that may have been added. So you can add comments. So if I click and all I did was click on the picture and I went into an overview, and you can see a place where you can see the assembly, you can see the parts, and you can add comments to it directly. Like here's a part what I would normally make on the orange vices. We would go in here and we'd set a part up like this with our stock and start to look at what we need to do to machine it. So this is only, I'm only in our browser right now. I'm not in Fusion at all at this point. So I'd like to see this part. I can go in and I can get, let's say, some properties right off the part, see what it's made of, see what kind of volume and area we have. I can also go in and I can, if I want to explode an assembly, I can hit the explode and I can explode that assembly. But in this case, it doesn't really make much sense, so I'm going to shrink it back down. But you might have an assembly of something that actually has like a functional view that you want to see. I can also do some planes. I can take a look at whether I want to have a section view. I can take a section view right across the part right here and see what it looks like inside of those holes, change the section view angle. So I have a really nice view on the part, do some section views there. I can also take measurements off the part. I can select this hole to this hole and see what that distance is. So I'm doing all this right inside the browser. I don't have to be in the part. Anybody can do this if you have access to that project. Okay, and we can add comments and write it up, and then I can send it on to the next guys. Hey guys, make sure you check this before you go to make it and so forth. But it's a really nice tool to be able to work with. Right inside your browser, and you can do this on your mobile device as well, and add comments and mark up and take measurements. So it's really powerful. And again, this is not PC specific. You can do this on a Mac as well. Okay, so it's a really powerful interface to work with. So if I wanted to open this in Fusion, I would just simply click Open in Fusion, and if I didn't have Fusion, it'll pop up and says now I have a chance to download and install. It's a small install. And it'll recognize whether you're working in, I already have Fusion open, and I already have another hub that I'm working with, but that's okay. Let's switch over in the background. But it'll also ask you if you're downloading, it'll recognize if you're on a Mac or if you're on a PC, and you'll be able to load it and work with it. So this is the assembly. I'm going to start one from scratch, a part from scratch, but I just want to show you I can access this assembly right inside of Fusion, right from that web interface, right from here. I can get that part open and start work with it, as long as I have access to it, and I can make changes if I'm an editor in that project. But since we're in Fusion, I'm going to start a new part. I'm going to switch over to a no hub. This is what it looks like inside of Fusion. I have access to those same projects right here in my data panel inside of Fusion. I have my model, the history, I have the bodies that are in here and sketches, and on the bottom I also have my timeline down here that I can move in and out of that timeline as this assembly was being built. So that's the basic overview. This is the workspace for model. I have workspaces that we can get into for patch, render, animation, simulation, CAM, and drawings. We're going to look at CAM mainly today. We're going to go into model and make a new part. So we're not going to work with this training part today, and often during our fast tracks we often go in here and add toolpaths, but today I think it's a good idea to walk through how to draw a part, model it, and get CAM on it. So I'm going to close out of this assembly. I'm going to switch my hubs. I'm not going to save anything. I'm going to switch the hub over to my own hub. So if I go up to my name right here, this is my account, and I have the different hubs that I work in. So if you're new to Fusion, you probably won't see any of these hubs, and you likely won't see this switch hubs because you haven't added any new hubs yet. But you will in the future as you start to work with Fusion. So here I'm going to switch over. Hopefully it's my top one there. I'm going to switch over to my hub. And it brought me into a Fusion project that I was working in earlier, but now this is my own personal hub. So this is the hub that I have projects in that I share with other people, and also where I practice and get ready for Fusion demos or get ready for training classes. So here, I'm in this hub, and I'm going to work right inside this Fusion Fast Track project. I have in my work holding, I did download a Kurt Weiss, but later on we're going to show you how to download it and upload it into the project. So I'm going to go back into this project here, and we're going to start a brand new part. So I'm in the model view. I'm going to close out of the data panel, and let's get started with a new part. So what I like to do is I'll expand the origin down. So right now, this is in my browser. I have the views that I can work on, top, right, front, and left. I also have the units that I could change real quickly, whether I'm working in millimeters, centimeters, or inches. And down here's the origin. I like to turn it on so I can see the origin, where that origin is as I'm working. Another neat feature that was newly added to Fusion is we can see where our Z is on the top and on the X. If yours is on the front, you can go into the preferences here, and Lars Christiansen recently did an awesome interface for how to work with preferences. So it's a good thing to Google that and take a look at what Lars did when working with your preferences. So what I want to show you real quick is the default modeling orientation. I have it set right here in my general preferences to Z up, because I like to have the Z on the top when I machine. And by default, a lot of CAD packages have Y up, which means the Z is going to be normal to the front face of the part. So I'm going to switch that to Z up the way I like it, say OK, and often, and I think in Fusion it's an instant thing where it has the Z towards the top. That's the way I like to work in the machine. That's the way I like to have my design. So this part, I'm going to work on this top plane right here, this XY plane. So my Z is out towards me. That'll be the top of the part. So I can right-click right on that plane, and I can say Create a Sketch. Okay, all I do is right-click on that top plane, and I'm going to say Create Sketch. And now I'm in this view where I can create the sketch. So I'm going to make a rectangle from the origin down. So I'm going to go up to rectangle. Now, in the sketch pull down here, you have a lot of different functions to work with. I'm going to choose rectangle, 2-point rectangle. I can also hit R. So I'm going to select that origin. As I hover over the origin, you see it wants to snap. That little box means it's snapping to that origin. I'm going to snap it and start dragging down to the right, because I want my origin to be the upper left corner of the part. That's the way I'm going to draw it, and that's the way I want it to be oriented. So I'm going to make this a 5x4 part. So since my X axis, I can see that red x-axis at my origin there, I'm going to make the x-axis be the 5, and I'm going to hit tab, and I'm going to make the y-axis be the 4. Hit tab again, it locks them in. And if I hit enter, now I have this rectangular feature. As you see, it put the constraints on here, which is horizontal and vertical constraints according to the plane in which I'm in. Let me do this real quick. Also, as we're working, you'll notice in GoToWebinar, we have a place where we have, you can ask questions. So as we're going through, if you have any questions, please feel free to expand that area down on the GoToWebinar and ask a question. And hopefully I'll get an answer. If I don't have an answer, I'll make sure I get one for you. Okay, so now I have this region. Notice when I hover over that region, it highlights. That's a region that's closed, and we're able to work with that region and do, and extrude it and work with it. So I have that closed region. I'm going to start the sketch in here. What I want to do is I have a part that's going to look like this real quick. Let me go into here. I'm going to look for, if I can spell, a carburetor adapter. We're going to make a part that looks like this. Similar to this, very simplified, but sort of like one of these adapters right here. We're just going to make it very simplified, but I'm going to show you how to make something like that real quick. Okay, it'll be like a Venturi type like this. Not specific, very simple. So this is going to be the overall base of the part, the size of the part. So I'm going to start the sketch, and as you can look at what we're drawing, they're quite symmetric. If you look at it, you can draw one corner of this, mirror it, and then mirror that, and you'll see you'll have a symmetric part. A square, quite symmetric part, or a rectangle. And that's what we're going to do here. So what I want to do is I want to add some symmetry lines. So I'm going to add some lines. I'm going to hit L. I'm going to start a line. As I hover over the midpoint, you see that triangle snaps to the midpoint. The same thing down here. I'm going to do the same thing from left to right. Notice on my cursor, I still have that line icon attached to it. It means I'm still in that function. So I'm going to click at the midpoint to the midpoint. And now I'm going to hit escape to get out of that line. You saw it was also highlighted up here. Now if I hover over, now I have 4 different regions on the part that I can do stuff with. So it recognizes those as 4 different places where we have access to extrude or do other things with. Now I don't want those 4 regions. What I want to do is I want to use these as my construction line. So I'm just going to select it, hold control and select that line. And I'm going to say normal construction, turn them into construction. Now I have 1 region again. I'm going to start to draw freehand right up here the shape of the outside of that part that I want. So I'm going to hit L. I'm going to have it snap to this line right here, and I'm just going to start drawing across. Notice as I stretch a line, I get a dimension and also an angle. So I can type in a dimension, tab, and an angle if I wanted to, but I like to draw freehand. I'm going to draw it to a certain distance here and put the dimensions later. So I'm going to draw it out and click it right there. Looks good. I get this little check mark if I want to end the function, but I want to go past it, so I'm going to zoom in a little bit. I'm going to keep drawing. I'm going to make sure you see that little right angle icon right down here that pops up. It's showing me when I snap to a right angle where I'm perpendicular to that original line. So I'm going to click it there. Now I have a perpendicular constraint. Drag it over, click here, and I'm kind of just dragging in space. I'm not worried about exactly where it's putting them. I'm just making sure I get this overall shape. And now I'm going to snap it to that line right there. So I have this overall shape, and just notice that all the lines are blue. I have these blue lines, which means it's not constrained at all. Well, it's constrained, of course, to right angles here, but I'm not fixed. I don't have any dimensions, so my lines are still free to. A quick question, how did I make it dotted line? So what I did was I selected a line. I'll show you right here real quick, Dennis. So if I select this line right here, and in my sketch palette, notice it changes when you select objects, the sketch palette changes. So I selected this line, and I went up here and I said normal construction. I simply clicked it for it to become a construction line. So if I click it now, you see that line now became a construction line. But I want to change it back, so I select it, and I click that again, and it changes it right back to a normal line. You got it, Dennis. So now what I want to do is I want to put some dimensions on here. So I drew it out freehand. I got my constraints. So it's a good idea to get constraints. Now I don't have a constraint between these two only because it's recognizing it as a right angle there. So if I grab a hold of this, I can pull it and move it. But I got my constraints, what's normal to each other. And now what I want to do is I want to add some fillets in here before I get dimensions. So I'm going to go up to Sketch, Fillet, and I'm just going to select this line. Notice I don't have any boxes popping up, but when I select this line, and I select a line that's normal to it, you see it starts to give me a preview of a fillet, and then it says how big do you want that fillet to be. I'm going to put in 1/8 of an inch. I want that to be 1/8 of an inch. Now, if I hover over any other fillets, notice if I go over the corner there, it recognizes that as an area where I can put that fillet. So I just simply select the corner. I'm going to do it here, 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 and now I have each of those corners with the same 1/8 inch fillet. I hit enter, and now I have, see the constraints right here. These are my tangency constraints, so I know my fillet is tangent to each of those lines. Okay, so now I have perpendicular constraints and tangent constraints, and I'm just still free drawing. So if I stretch this, it takes those constraints with it, and you notice it wants to still have that constraint even though I stretch it the other way. So be careful if you're going to have constraints and you're going to put dimensions that put the line in the wrong place. But now let's add some dimensions. So I'm going to go up to dimension, or we can hit the letter D. Okay, so I'm going to click dimension, or hit the letter D will get you dimension, and you can see the dimension attached to my cursor right there. So I'm going to work my way around. I'm going to start the dimension from here to my datum. There's my datum point, so I'm going to say there's my datum line. And that's going to be 1/2 inch, so I'm going to put 1/2 inch there. Okay, and I can also put it here, so it's 1/2 inch there. I'm going to also put 1/8 of an inch from between here and here. So I'm going to make that 1/8 of an inch. Okay, enter. Now I hit enter, and it looks like, and it appears I'm not still in the dimension mode, right? If I'm not, I just hit D and I go right back into dimension mode. So I'm going to select that line and my datum, and I wanted that to be also 1/8 of an inch. And the same thing here. I hit D, and I want to make this 1/2 of an inch. Oops. From here to my datum line there, I'll make that 1/2 inch. So now that we have these dimensioned, you notice that they turn black. The lines are now black, which means I can't move them around. They're not free, right? Now I have those constrained where they're at. But these I can move around. So if I grab that little center of the arc there of my fillet there, I can move these around free because they're blue and they're not constrained. Well, I do want to make this width, overall width of these, 1 inch and 3/8. So I'm going to go 1.375. Now it's locked. And now this one, the width between here and here, I'm going to make that 1 inch. Now, even though my cursor doesn't show it, I am still in dimension mode. If I click something, you'll see a dimension start to pull off of it, even though I don't have the icon there. The reason I know this is because when I look at the icon up here, I can see that blue icon is still highlighting the dimension mode. So I'm going to hit escape to get out of it, and you'll see that turn off, and I'm back in my selection mode. Okay, so keep an eye up here sometimes on what's highlighted. It'll give you a hint as to what's going to happen next when you go to click something. Okay, so the next thing I'm going to do is I'm going to put a slot feature in here. Okay, I'm going to add a slot. So I'm going to go up to Sketch. I'm going to go down to, where am I here? Slot. Center to center slot. And I'm going to start drawing arbitrary in this area. I'm not going to fix it to a place. I'm just going to start from there. Right? And I can change the angle, and I'm going to go to there. Kind of arbitrary in space. Now if I pull away from where I left off, now I see it stretching the diameter of my slot. And I want this to be a diameter of 3/8, so I'm going to put 0.375, enter, and now I have this slot. Now keep in mind, even though I started it and started stretching it horizontal, doesn't mean that it is a horizontal fixed part there. So if I start to do that, sometimes I can actually swing this thing around. But keep in mind, oh actually, it did. See this horizontal right here? It did put the constraint. Sometimes it doesn't. Sometimes that horizontal constraint isn't on there, and you can do this, which is okay. You might want it like a sideways slot and put a dimension on it. But if you want that to be horizontal, select the center line. And notice when you select the line, the constraints in the sketch palette changed. And I can put right here, horizontal, vertical. Since it's closer to the horizontal, I can choose that and it snaps a horizontal constraint on there. So now my slot's going to be horizontal to my X here. Okay, and I can still stretch it in and out because those dimensions aren't fixed yet. So what I want to do is I'm going to actually fix the center from width to width. So I'm going to select dimension, and I'm going to select that line in the center there, if it'll let me. There we go. And let's make this 3/4 of an inch. Yeah, I'm going to make it 3/4. Okay, that's how wide I want it to be. And now I want to fix the width from my datum to the center. And I want that to be 1/2 inch. Okay, now I want to fix my datum to the center of this. Now, let's say I wanted to get to the edge of that line. And this came up in the training when we were at the build space. What if we want to get our dimension? I'm going to stop out of this for a second. What if we wanted a dimension from here to that edge of the slot? I want to control that distance, not to the center because I can't really measure that well. What we do is in dimension, hold shift. Select your initial datum. Oh, let me go back up to dimension. I'm going to select my initial datum, hold shift. And now if I hover over, you see it snaps to the quadrant. It'll snap to that midpoint in that quadrant right there. And now I can get a dimension right to that quadrant. And I'm going to make that 1/4 inch. Now, hopefully that's helpful. Sometimes, I mean, we thought about that a little bit, but it's great that the guys, developers in Fusion have added that functionality to be able to hold shift and then snap to the midpoint or the quadrant there. Okay, so now all the blue lines, it does actually. Shift does work in Inventor as well, Dennis. You can use shift in a lot of those functions, but when you use it in dimension, you'll see if you hold shift, it'll also find the quadrants and the midpoints as well. So if we look at this sketch, it's all black and it's all fixed. So there's no blue that I can move around. Sometimes I've noticed places where this line and this line will stay blue in your slots, but it's still fully constrained. And I think that might be just something in the graphic view or the way that it works with the graphics of a line. But if that happens and you can't move it, test it. See if you can move it around. If it doesn't move, it's fixed. Okay, so now I have these features, and I want to mirror it down here. And I have all these constraints in a way. So if I try to grab something, I click the constraint. You can hide all that. If I go over here and I say show constraints, I'm going to hit the little check right here and hide them. Just makes it a little bit easier to see what's going on because I don't need to work with the constraints right now. Another thing in Autodesk, and you'll see it in a lot of other CAD softwares too, if you start a line, I'm going to click right in here. You're going to start a selection box. I'm going to click right in that little middle of the box right there and start to drag down to the right. I get this closed blue line and sort of orange box. Now whatever falls inside of that box is going to get selected. If I start from the right to the left, I get this dotted line box with a yellow box. And that means whatever the box touches is going to be selected. So whatever that box touches is going to be selected. So if I started it down here like this, and I start to go like this, whatever the box touches, that's what's getting selected. If I start from the left to the right, like this, whatever's inside of that box is going to get selected. And what was in that box was my slot and those lines that I drew. That's what I want to mirror. So I pre-selected what I want to mirror. You can do this, or you can select it after. I'm going to go to Sketch, Mirror. This is our mirror palette right there. And you can select the objects here, but I've already selected it so it knows there's 40 objects selected. I just simply have to select the mirror line, turn this blue, select the mirror line, and it flips it over and you get a preview of what it's going to look like. Okay, that looks good. I say OK. There it is. I mirrored it. Now, I still only have one region. Well, actually, I have 3 regions where my slot is. You can see the difference. And a region where this slot is. Now I want to be able to flip all that to the other side of this line. So I'm going to go up again the same way. I'm going to select inside of here, drag a box. I'm going to select all that's inside the box and do another mirror. Mirror, select my mirror line, and then it mirrors it to the other side. So I have a nice symmetric part. And now if I hover over, you see the different regions we have. It's closed. It's a different region to work with. So as we start to build our model, we can choose these different regions to cut away and add and grow and so forth. So now I'm going to add one more feature. It's going to be that body above where the throttle body would be, down to the venturi of the intake manifold. So I'm going to draw that in. I'm going to make a quick a rectangle. So I'm going to hit R for rectangle. My cursor now has a rectangle added to it. And again, I'm just going to start a rectangle in space. Now I know that I want this to be 2, so I'm going to say 2, tab, and I want this one to be 3, 3, tab, and it locks them in place, and I hit enter. Now I have this rectangle. But notice it's blue. So I can grab a hold of a corner and I can move that rectangle anywhere I want to. But right now I have it sitting sort of in the center. But I'm going to show you how to constrain it to make sure it's in the center. I'm just going to pull this dimension down here and this dimension out here. And they're kind of ugly, but I'm going to go back and fix my dimensions there so they look nice later on. So now I have this rectangle, and I want to put some big fillets in here, a 1/2-inch fillet around. So I'm going to go up to Sketch, go down to Fillet, and again, I'm going to start down here, right? Select that. Wow, it knows I want to do a 1/2 inch there. So I'm just going to continue that around. There we go. I'm going to hit enter. Now I have some fillets around the part. Okay, so I'm still kind of floating here. Now I can add dimensions. I can add a dimension from my datum to the corner there, but this is really a symmetric part now. I want this thing to be symmetric about the center. So I'm going to add symmetry. So I'm going to go down here to symmetry right here on my sketch palette, select that, and then when I hover over an item, it says select the sketch objects or change constraint type. Well, I'm going to select this one, select second sketch element. I'm going to select this one, select symmetry line. What do I want those two to be symmetric about? I'm going to select this center line right here. Select, there it goes, give it a second, and now I have symmetry about that center. You see those lines turn black? While I have symmetry still on, I want to make these two symmetric as well. So I'm going to select this line, and then I'm going to select this one as my second element, and I'm going to select this center line, and that's going to be what it's going to be symmetric about in the center. Now my sketch is now blue. So now I can't move it around. It's constrained, and you can see it has symmetry around it. If I turn my show constraints again, you'll see we have this symmetric icon right here and the symmetric icons right here. So our constraints are showing us that it's symmetric. We have lots of constraints in here only because we kept mirroring those features. So I'm going to turn those constraints off just to make it a little bit more clear to see. Again, the same thing I'm going to do, I'm going to make an offset. So I'm going to go to Sketch, Offset, grab a hold of this, and I can drag this down. I'm offsetting that feature. I'm going to make it a 1/4 of an inch, offset, and now I have that feature offset. Finally, I'm going to have a slot in the center that we're going to make a venturi down to that slot. So I'm going to go to Sketch, Slot. I'm kind of hurrying up because I realize there's a little bit more we want to cover with uploading an assembly. So we're going to make this part. So I'm going to select from here to here, drag it up, and I want this to be 3/4 of an inch in diameter. Give it a second, and we can do the same thing. We can make this thing symmetric, but what do I want the overall dimension to be? I'm going to hit D for dimension, and the width of this guy, not that guy. I can also do it this way. I can grab that endpoint, and I want that to be 1 inch. Okay. All right. So now we kind of have this shifted off to the side. I'm going to hit escape, so I'm not doing dimension anymore. We kind of have this off to the side. We can kind of drag that back and forth. So what I want to do is I want to make that symmetric as well. And we could do the same exact thing. Where are you going here? Hang on a second. There we go. Oh, come on. So I'm going to make that symmetric as well, between here and here to the center line. We could do the same exact thing in a slot. I'm going to select that center point, and that center line, and it's going to add symmetry. Okay, so that's the basic part that we want to make right there. So let's make a model out of it. So I'm going to stop that sketch. Sometimes I don't put all those features all in the same sketch. Often I'll create alternate sketches or different sketches on the plane. Only because there's sometimes I want to turn sketches and features on and off to be able to machine the feature before it and then turn it on later to be able to get that machine part, that machine feature. But for this webinar, I'm just drawing them all in the same sketch, and I'll show you how to make a model out of it. Okay, so we want to make this a model. So the first thing I want to do is I want to get the overall shape of my model. So I'm going to show you how to extrude that down. So I'm going to go up to Create, Extrude, or you can hit E for Extrude. Working my way from the top to the bottom, I'm going to say, what do I want to select as my profile? If I hover over, you see all these different features that highlight. These are the different regions that we can use to make a model out of. So if I selected this outer region, you'll see that turn blue. I want to select these slot regions too. So I want to get the overall part. So I'm going to select all these regions, and that's what I want to extrude. I can grab a hold of this little arrow and extrude it up. In this case, I want to extrude it down. So notice as I move it in a different direction, you see the dimension change from positive to negative because it knows where my 0 is. So I'm going to go down here, and I'm going to make it a ½ inch. So I'm going to put in negative 0.5, hit Enter, and it made this feature a ½ inch thick. Okay, so now notice my sketches turned off. The light bulb went gray, and I don't see those sketches anymore. It doesn't mean we can't still work with them. We don't have to create new sketches. I just simply have to turn it on right here. So if you don't see it, expand down under sketches, and also notice if I expand bodies, we now have that body in our feature tree that opened up. So if I go down to sketches and I turn this on, the light bulb, now I can see all those sketches and continue my work. Now let's say we want to extrude this down. We're going to remove this area right here through the part. So I'm just going to go up to Modify. Right? I'm going to select that edge, and it knows we're going to do an extrude because it's smart. It recognizes what we're doing, what we've selected. I'm going to grab that arrow and just start to drag it down. And notice it wants to cut that red. And down here, notice it turned into a cut in our operation. But if I start to drag it up, it switches over and says, oh, you want to join a body onto there. So it's really smart with knowing what it is that we're trying to do. So if I pull it down, it knows we're trying to cut through the body, and I could drag it all the way down. I don't have to give it a finite depth. Let's say -1 is where it ended up. I hit OK, and it just cuts right through the body right there. I want to do the same thing with these slots. So I'm going to go to Modify. Just going to select the face of those slots right there. And I want to make them 1/8 of an inch into the part. I just start dragging it down. And I want it to cut -0.125. Enter, and it cut those slots down 1/8 of an inch into the part. Now I'd like to add some holes, guys. I want some holes in the center of those slots. Now I didn't really draw a circle for the hole. I didn't add any of those features, but I want 1/4 inch through each of those. So I'm going to go up to Create, Hole. Okay, and I'm just going to select this center point of the slot right there, and it recognized that's an area where I want a hole. My diameter is 1/4 inch. Sometimes it doesn't start that way, but if not, you could just type in 1/4 inch. How far do I want to go? I want to go through all of the part, or I can go a distance. I can make it drill down, you know, 1/8 of an inch or whatever, 1/4 inch. But I want to go all the way through, and I want to select additional holes, like this one, this one, this one, right here, and you can also select the center point of the edge there too. But it got the center points of those slots. Say OK, now we have some holes drilled through. Okay, so now I want this boss. I want this to be a boss 1/4 inch up, so I'm going to go up to Modify. I can also go to Create too. It works as well because Modify recognizes what you're trying to do. So if I go to Create, I can create and grab that edge, and I can extrude a boss up from that sketch. Not a problem. I can also do it with Modify. But here I'm going to extrude it up 1/4 inch. Now we have a boss on top. And now what I want to do is I want to have a loft. I want to have that venturi go down to the bottom of the part, and on the bottom of the part I want this feature. So here's what we would do. I'm going to make a new sketch on the bottom of the part. I'm just going to select the bottom of the part, right-click, Create Sketch, okay? And I want that slot feature right there to be on that sketch. So I'm going to go to Sketch, Project Include, Project, where I can hit P. I'm going to select these lines right here. And notice it projected them down onto that sketch plane that I wanted it to. So it just borrowed, I just projected what I already drew onto a new sketch plane. I'm going to say OK. And now what I want to do is I want to make a loft between this feature down to this feature. So what I do is go up to Create, Loft. This is our loft interface here. What's the profiles? And I can choose it by rails too, but I didn't set it up that way. But I'm going to use this face and this face so that they're all one face. And what do I want to have it go down to? I want it to go down to that face. And it recognized the features and it made a loft. There's my little Venturi down to that face. There's my preview. I'm going to say OK. And now I have a cutout. Let me hide this sketch real quick so you can see it better. And now we have that cutout down to that lip. Now I probably would want to add a lip on there, but now I have this little Venturi feature, which is a 3D feature, down to the bottom of the part. Okay, and I'm realizing that I took a good time getting here, but I want to show you something else that's important. I'm going to now save this body. Let me go in and save it. So I go up to Save, and it wants to know what project. I already started out working in my Fusion Fast Track project. Okay, I'm not going to work in the work holding, so I'm just going to go back to that Fusion Fast Track. So I'm going to go into my Fusion. Let me go up here, scroll this up. I can select any of these projects that I want to work with. So let's say I want to do my Fusion Fast Track only in that project. I can select any project I want to save it in, as long as I have access to it and can edit and save. I'm going to call this one my adapter plate. There's my adapter plate, save it, and now I have this adapter plate we're going to add some cam onto. Now, I want to be able to have this put inside of the vise that's on my machine. I have a Haas D810, that's what we had at the at Pier 9. So that's what I want to put this into. So I'm going to go quickly, I'm going to go into Google, and I'm going to search for my Kurt, not Haas, Kurt D810 vise. It looks like I found it earlier. There's my Kurt D810. Okay, I'm going to scroll down to the bottom. A lot of our work holding companies, manufacturers will do this on their website, will allow you to get a preview of a solid model and be able to download it. You can get 2D, 3D. In this case, I'm going to download a 2016. You could do 2017, just want to make sure it's going to open, but I've done this before, so I'm going to work with the 2016, and I don't want to zip it, but I'm going to download that part. This is what I want to download. It downloads to my downloads folder. I can say show in folder, and here is the part I just downloaded. Looks like I've done it before, so it made a couple copies. Here it is, what I did before. So there's my, actually right here, my Kurt. That's the one I downloaded. That's the part we want. So I would just simply copy this to a folder that I normally work from. So on my desktop, I have a folder called Fast Track Webinar. Looks like I did this already in my practice. So now I have this Kurt D810, the same part we just downloaded. It's a SolidWorks part in my Fast Track Webinar folder. So now I want to upload it into Fusion. So I want to get it into here so I can work with it. So if I open my data panel, okay, in my work holding, I'm just going to try to upload it right here. So there's a button where I can upload. It's saying select the files that you want to do. And I can always go and look for, my desktop and find that Fast Track Webinar. There's the part. Open, upload, and it starts to upload in the background. Looks like I tried it earlier and it failed. Sometimes that happens, especially when, like when I'm on GoToWebinar. Sometimes this stream can take up a lot of my bandwidth, and I've noticed before that it'll happen too. But it looks like it's going pretty quickly. So you might be able to work with this part directly, which would be awesome. But sometimes that happens. So I can close this and I can see that there's some progress going on down here. So while we're waiting for that, I think it's uploading, it's going to finish, we can work with it, and I'll show you how to make an assembly out of that. While we're waiting, I'm going to real quick, what I didn't do in here, I didn't create a part that represents my stock, because it's sometimes helpful when I go to put parts into a vise to actually represent what's the actual stock of the part. So I can always go back in time. I can stretch this back, and I can see the original part I extruded. My part's going to be a little bit different. I'm going to leave some stock on the top and on the bottom. So what I want to do is I want to create a new sketch on that same plane. So I'm going to go up to my origin, and I'll select that same plane, right-click, create a sketch, and now I'm going to sketch that rectangle that represents my stock. Now I could use that same sketch and project it, but I'm going to do it right here because it's easy. Grab here, and again, I'm going to make that, this one was 4 by 5, hit tab, lock it. Now I want to extrude. I'm going to stop that sketch. I want to use this area to extrude that to be representing my stock. So I'm going to go into, let me close this out real quick. I'm going to go into here, and I'm just going to say create, select, and I'm going to drag this up, and I know that boss is 1/4 inch above that plane. But as I do this, you notice it wants to chop off the part. It thinks I want to do a cut. Now down here, I'm going to change that from cut. I'm going to say new body. So now it knows I'm trying to stretch a new body onto here. So it's going to actually create a new body that's not adjacent or not part of my original model. So I'm going to stretch it up 0.30. I know that's going to be 50 thousandths above the top of my part, above the top of my boss. And now I'm going to choose the other direction. I'm going to choose, instead of direction one side, I'm going to say two sides. And now I can stretch this down 0.70 to make an inch overall stock piece. Okay, so I'll leave, 30 or 300 thousandths underneath my part to hold on to. I'm going to say OK, and now I have a new body right here. I have my original body, and now the new body that represents my stock, I'm just going to simply call that stock. Okay, that'll be my stock. Okay, and I can also change, if I want to be able to see through it, this is just a trick real quick. I can change it, and I can go into, say, physical material. If I want this, where am I here? If I want this to be a specific, let me move this over for you. If I want this to be like the real material, we can do that, but I can also do something like this. I can make this become glass, and I can actually see through it. Click and drag and put it on. Because the main reason I did this body is that I can represent what is my stock, what's my stock size, but I'd like to also see the part inside when I set it up. So it's just a graphical representation of that stock, but it's helpful when you're setting up for CAM. So a trick is that I just made it become something see-through. That's just a trick that you can do. Now, of course, you can make it, of course, the actual material if you want to do some calculations as far as the actual material that's being removed from the part. But I just did it just because I want to use it as a graphic when I go to load it into the assembly. Okay, so now I created the stock. I can go down here and hide that stock body for now. You just turn them on, turn them off. So I'm going to hide that and save it. I'm going to say added stock body. Now, it's a good idea to add a version description because when you see it's going to update to a new version in your browser and you're letting everyone know what's changed at that version. Let's see how we're doing with uploading. Looks like it's still uploading. Sometimes that happens. Sometimes when you're uploading and you have things uploading and downloading and you're using up a lot of your bandwidth, you'll see it'll take a little while. Most of the times it doesn't. When I'm not doing webinars and meetings, it's usually pretty quick. But I did open up one earlier, and this is the actual one. It's version 1 because I brought it in and saved it, but this is the actual one that I'm uploading here. So I can open up this one and show you how it works. So I'm going to right-click, and I'm going to open in Fusion. There's some other things you can do, is open them together, but I don't want to make a composite design. I can also make a new drawing, but I want to open it to work with it. So I'm going to click Open. Okay, and it brings it into my graphics view inside of Fusion. I have the adapter plate. I have the graphics view of my Kurt Weiss. And I'm going to go a little bit quickly because I'm realizing we're getting close to time. So what I want to do is I want to make this a template to be able to put my part into and add my toolpaths. But right now, is if I turn on my origin, I can see the way my machine would be set up with my Z on the top, right? My Y is going back into the machine and my X is going to the right. I want my vise, the body, the main body going into the machine, and this jaw to be along the X. So as you can see, when it comes in, it's not in the right direction. So let's change it. If I expand down bodies, I'm going to close this out. We don't need a data browser at the moment. But if I expand down bodies, you notice this part is made up of all these different bodies right here. And the bodies, they're just different parts pulled together to make up that one body. But we don't have any origin, we don't have any planes, we don't have anything to really move those bodies around. But that's a good thing for now. So what I want to do is I want to grab all those bodies that make up this composite model. I held shift, I select this one, hold shift, and it grabs all of those bodies. I'm going to right click while I'm on top of the blue area of any of the bodies. I'm going to say move copy. What I want to do is I want to reorient this model. Okay, I want to reorient it. I didn't get, hang on a second guys. I want to be able to move, and I don't see my orientation here. Let me see real quick. Bodies, yes, point to point. Ah, here's why, okay. Let me go back, I'm going to show you. So I'm going to right click and say move body, move or copy. And now I have it set up there, I'm doing point to point, but I want to do a free move at this point. Okay, the third selection down here, the move type. I want to do a free move, only because I'm not trying to move it from point to point, I want to reposition it. So the free move lets me do that. You see all these pivot handles here that we can pivot it around the center point. So what I'm going to do is, I can also set that point to the origin too, but I'm going to do it this way. I want to be able to pivot it around, like I'm going to slam the bottom of that vise onto my table. Boom. Okay, I slam the bottom onto my table, which is this plane. And now I want to rotate it around this way so that now it's -90. Now my Y is going into the table. Now this body is along the Y. And now my plate, my jaw plate is along the X right here. So that looks good. I'm going to hit enter, and now I've repositioned that part. Now I want to get my origin. Let's say we want to set our origin right at that top corner right there, that corner of the jaw plate. So I'm going to highlight those bodies again, hold shift, right click, move copy, and now this time I want to do a point to point move, and I'm simply going to select that point, and I want to put that point at the origin, so I'm going to select the origin. You see this little stretch band snap right to the origin. Now I have that set. Now I like to set it up in a way that I can just simply select the origin of my template to be my G54. You don't have to. That could be a dowel pin hole on your fixed jaw. It could be anywhere, but in this case I'm going to set it right at that top corner of my jaw on the fixed jaw. Okay, I'm going to say OK, and now I reoriented, and now I've moved this, so now it's located exactly the way I would want to see it in my machine. Okay, now the next thing I want to do is I want to make this a moving jaw. I want to be able to move this jaw back and forth and to be able to put my part in it. To do that, I have to make these bodies become components. The way I do that is I select the first body, shift down to the bottom, and I'm going to right click on those bodies, and I'm going to say create components from bodies. And now if you expand these components down, each one now has an origin and a body, an origin and a body. So we can move each of the components separately. So now, like if I grab this, I can move this out, and I can grab this and I can move that out. But I really don't want to do that. I'm going to undo a couple times. What I want to do is I want to fix all the fixed jaw stuff, all the fixed stuff, and I want to have moving as a group all the movable stuff. So I can put a part in here and move that jaw around. So what I want to do is I want to select those components that I know are going to be fixed and not moving. Okay, it might be a little tedious sometimes, but you got to select the right parts. That's my fixed jaw plate. There's my fixed jaw, and then there's bolts. There's a fixed jaw bolt, another bolt. Sometimes they're not in order, and that's okay. As you go through here, you can see, and they highlight, and you can select those components that are going to be fixed. So I think I might be missing one here. There. I don't want to select that body. So those are all the bodies that I want to have fixed. So I'm going to right click on top of anything that's blue and ground them. That little icon with the pin means that they're grounded. I can't move them around. They won't let me click and drag. But the parts that aren't, I can move them around. Let me undo that a couple times. Now what I want to do is I want to make this a group. Right? So I'm going to go in to select the ones that I didn't ground, which are my moving jaw. I'm going to right click, and I'm going to say a rigid group. And it groups them together even if there's child components. In other words, if there's a subcomponent in here, I can also select that subcomponent. Say OK, and now notice a new folder of joints is now added. So now if I move this thing around, if I hold Alt, it's going to grab all of those components together. And that's what I want. So real quick, I know we're getting close to time. I hope you guys don't mind if I go over a little bit. Hopefully this is helpful for you, what I'm going through to show you. So I want this front plate and this front plate to be aligned as a joint so I can slide this thing back and forth. Okay, so I'm going to go into my Assemble, Joint, and it recognizes the first component that I have, which is all these components together, which is a rigid joint, which is rigid body, all these bodies together. My first component I'm going to select, it's highlighted blue here. And what I'm going to do is I'm going to select that face right in front, right there, right in the center of that jaw. And now it's saying, what do you want this to join with? And I'm going to select this jaw right in the center. And it comes over, and that moving around means it's going to be a fixed joint, as if I'm bolting it or welding it together, right? But I don't really want to do that. Down here, I have the type. Now, I recommend going through our training videos, especially online with Fusion, to learn more about how joints work. But what we're doing is we're putting in a realistic movement of how the assembly is going to work in the real world. And here I'm going to have a slider joint because I want them to slide. And now you see that face moving back and forth and sliding from each other along the z-axis, what it considers the z, a normal to what we're selecting. So keep that in mind. It's always relative. Okay, so I'm going to say OK, and now you'll see as I grab a hold of this, now, as I grab a hold, it's going to slide, and those two faces are going to be adjoined to each other. Now, I can slide it through, and that's kind of silly, but at least I have it sliding in that plane. Now what we can do is we can add some limits so it locks down, realistically the way it would be in the vise. Here's how we do that. If I see expand down, you see how we have this slider 2 joint right here that we just created. If I right-click on that joint, I can go and edit the joint limits. And now I can say my minimum, when they come together, should be 0. And my maximum, as it goes further away on this vise, should be 8. So I'm going to make that 8. Okay, I can animate that, and you can see it's only going to show me that one feature, but they're a rigid joint, so the whole thing's going to travel together. I'm going to say OK, and now if I slide them back and forth, it slides 8 inches, 0, 8 inches, 0. So now I have this fixed here. Now, our expert elites, and I think there's a couple on this webinar, who work with this, and they go, and they're awesome, and they go and they set this up that when you turn the crank handle, it actually turns like it really will in the real world. And that's so awesome. And you can do that. You could take some time to put in some real joints and mimic what goes on in the real world, and it's fantastic to be able to do that in Fusion. I love it. So, but I'm not going to do that here. I just simply made this joint here and be able to move the part back and forth. Now, I want to get my part that we just created in here to be able to set it up for machining. Let me go and do that. So I'm going to stretch my jaw a little bit back here. So let's do that. So first I got to save this as an assembly. And what I want to do going forward now, this is going to be my template. This is going to match what I have in the machine today. So I could just bring any part in here over and over, and then I don't have to reset my G54. I don't have to reset any other things. I'm going to use this as a template of what's on the machine. I also want to start capturing the history down here. Notice that all those things we did, it didn't capture any of that history because I never turned it on. So down here, I'm going to right-click, or up here, on the Kurt vise, and I'm going to say, I want you to capture design history now. So now you see there's a timeline down here. Do you see this? A timeline that has all the stuff that we're working on that we can expand and always go back and make any changes to those things that we did. So make sure you turn on capture design history, and now we're able to go back in the history of the part and future what we add in here. Okay, so I'm going to save this now. I'm going to go up to save, and in my project, I'm going to save this as, I'm going to go, well, it's actually using a version. This is my HOS D8. I'm going to cancel this for a second because I want to do a save as. File, save as, and I want to put this in my work holding. It recognizes where we're at. And I want to call this one my Kurt D 810 fixture or template, because I would use this as a template going forward. And as I add CAM in this template, I can save my tool libraries. I can save, my tool setup for that machine. I can save all my templates, my toolpath templates and such that I can work with inside of this template. So it's a good idea to do this. So now I don't have to start from scratch every time. I can just use this as an empty machine ready for a new part. So I call that my template. Of course, I would save it as something else. But let's bring this adapter plate in there and start working on it. So what I'm going to do is I'm going to go into my data panel. I'm going to go into my main project. There's my adapter plate. I'm going to right click and I'm going to say insert into current design. Click insert into current design. The part comes in and guess what? It's already oriented. The zeros match up. You see that? Because I drew it that way and I assembled my template, I don't have to do much. I just bring the part in. Now, of course, it's not always going to be that easy for you. Sometimes you're going to open up customer parts, you're going to download parts, and it's not going to be that easy. But the point is I want to show you that if you set your model up with the intention of the way you're going to make it, it's easy when you bring it into your assembly and set it up the way you're going to make it. Now, honestly, it's not always going to be that easy, and you're going to have to set up joints and work with it, right? So you can move the part around right here. Just grab a hold of this, move the part where you need it. So I'm going to stretch the part out here. I'll show you the joints where we can set it up. But that's going to be the top corner. That's where I'm going to have the part. So I'm going to say OK. Leave it right there. So now what I want to do is I want to apply some joints onto here. Now I don't have to see this origin. What I can do is I can go down here and turn off that origin, or maybe not. It would be nice to. I think I'll put it in the idea station to be able to turn that on and off when you have a inserted part. But I'd have to open up the part to turn off the origin. That's okay. I can work with it. So what I want to do is I want to see that body that we created. So I'm going to have to go into the body anyway. But I want to see that body, that stock body we created, to apply the joints to the assembly we made. So I'm going to open it real quick. While I have it here actually already open, I'm going to turn on the stock body and I'm going to turn off the origin. Okay. In fact, I can even keep both bodies on. It's okay. But it's your preference if you want to turn off the stock body. Save it. That's okay. Go back into my adapter. So we need a little bit more that we have to do. Now, notice when I make it a change to the part, I have this exclamation point right here inside the yellow triangle. That means something has updated in our part. So I'm going to go up here and update, and it should change the part over, and we'll be able to see the stock body, and it turned off the origin. Okay, so I want to add some joints here, just the same way we did for the moving joint, for moving jaw. I'm going to make a joint on this side of the face to there. So I'm going to go up to modify, assemble, joint, and I want to assemble this face to this face right here. Okay, and it sees it as a slider joint. I can also change that slider joint, or I can make it a rigid joint, which is what I want to do. I make it a rigid joint, and it's okay if the part is sitting down into the model. What I would do is I would go and create a distance here. Another way to do it would be from the top face down, right? We can do it that way. We can do from the top face down. But I can also drag it up to get a good idea of where I want that part to sit, so I have enough that I can machine off. You can do it here, or you can do it from the top down. Let's say we do that. Let's say we did from the bottom face to the top face and add an offset. So I'm going to keep that as a rigid joint at 0 offset for now. Okay, so it puts the part right there. But I still have the freedom and the ability to be able to move this part around, I think. I did make it a rigid joint. What I can do is this. If I go up to Assemble, Joint, select this face, I'm going to select this top face. It's saying you already have a joint. Do you want to continue? Yeah. Okay. And now it knows that these two faces are joined. What I want to do is I want to add a distance down that I'm going to be into the soft jaw. And let's say we did it a -1/4 inch or -1/8, -0.125. When I finish this step, keep in mind, when I hit enter, it makes a liar out of me. Normally, what I'd like to see is this keeping this face and then the top of the part going down into the part. And I think it's not letting me do that joint because I made it rigid. So if I go back into that joint, this slider joint where I have it rigid, if I right-click, edit joint, I can also make that become a slider joint as well. And it's not working for me. Well, that's okay. But the idea is here that you can be able to add these joints. I'd have to start over a little bit because I didn't do the right thing. But what I want to make sure is that when I do these joints, because normally I would start from the top and then add a joint where it lowers down, and then I would start from the side to the side. And I would add a joint from this side over, but it looks like it's doing from the center there. So what I probably would do is I would do it this way. Let me right-click. Let me delete that out real quick. Delete. So then we could do something like this. I can grab this face, right, and I can make that assembly for my joint, right, and I can grab, exit out of there, I can grab this face, and I can grab, oh, you know what it is? It needs to know where we're selecting the center at. And this face, like that. So now I can add that as an offset. And this is where I would probably do it better like this. And now I can stretch that down, and I can say I want that to be negative 0.125, and that's probably the better way to do it. So now we actually applied a joint at those two edges and those two faces of the part. And I could do the same thing on the other side, and then we can set it in the center or set it where we need to, if that makes more sense to do. So let's go through that again. So I would go to Assemble, Joint, and again, I'm going to go down to this face. I'm going to wait for that icon to turn to the side because it knows it's that edge and that edge that we're trying to make a joint. And it should work for me here. I want to make that a rigid joint. Slider, rigid, and that should work for this. Not the corner, you silly. I want to make this 0, offset X 0, and let me get out of here and try it again. There. There. There we go. That's what I'm looking to do. Okay, so it recognizes the depth we did from the first joint. I'm going to say OK. And normally, that should slide over for me. Okay, so I have to practice too, guys, on my joints as well. Because that would normally slide over for me and then would have it sandwiched in between like this. Alt, rigid joint. Let's go and suppress that for a second where it would do this for me. So we have to practice, and I have to practice too to make sure I get it. But so that's what we want to do. And then we're going to add the joint from the 0 point to where we're actually sitting it, where we have like, you know, maybe you have some parallels underneath it here. You have a stop right here, and you can model it and make a joint right to the stop. Okay. So we are over. I want to put some toolpaths on here real quick. And this is the basic idea of what you want to do to set up an assembly, make it your template, being able to bring in your part. And now I'm going to put in real quick some quick toolpaths on here so we can get this to machine real quick. Okay, if it's all right with you, I know we're over. Hopefully this is helpful for you as we go through. So let's go and get some toolpaths on here real quick. So I'm going to go into, I have to go into my part, and I'm going to hide the stock body. Yes, this will be recorded, and I'm going to have it uploaded to our Fusion site as well as our HSM site so that you'll be able to get to this recording. So you go to our main site, website, and also we can also go through after the webinar to get information out to you where you can record or see the recording of this. Okay, so I turned off the stock, so I'm going to go back into my assembly. I'll make sure I save that to the latest update. I'm going to go back into the assembly. You'll see that there's been an update. Now it's going to switch back over to my part view without the stock there, and now I can use that to set up my stock. Okay, let me update this again real quick. So I'm going to use that body to be the stock as we could do a setup. Now let's switch over to CAM. Okay, so I'm going to go into CAM, Model, CAM, go into my setup. So now this is our CAM workspace, right? And this is our CAM workspace. This is our browser, and this is our workspace. Starting from left to right, I'm going to do a quick setup on the part. It recognizes the entire assembly. Okay, I'm going to tell it, starting from top down, that I want to do a milling operation, not turning. my model orientation is okay. I want to make sure, actually I want to make sure I'm modeling only that one part. I'm going to machine that one part. So I'm going to exit out of those 16 bodies and I'm going to simply select that part. Okay, there's the part we're going to machine. And I'm going to have my model orientation looks good. My box point, I can also tell this to use the model origin. Using the model origin in this case snaps it to my origin of my assembly, so it knows that's my G54 right there. You don't have to. You can also set this top corner of the stock to be the origin. So I'm going to say stock box point, and I can set that to be my G54 and touch off if I probe there. So it's real easy to set where your datum is, where your origin is. My stock size, I can do a relative size box, I can do a fixed size box, but you know what? We made a stock body. We made a stock model that represents our stock, so let's use that. So I'm going to go to From Solid. Okay, I'm going to go over here, and I'm going to expand down. I'm going to move this over. Down here, here's the body we used. There's the bodies. There's my stock body. I select it, and it uses that as my stock. I'm going to say OK. I'm going to expand this back up. So now my setup is actually using, I think I hit OK quick, but my assembly, now in this, it's using the actual stock body that we created when we were in the model. Okay, so I went through and edit. I went through and chose From Solid, expanded this down, and selected the stock body that we created in our model. All right, so let's get some toolpaths on. So the first thing I want to do is I want to rough out all this material as best I can, most efficiently. And we have an really efficient toolpath. But first I want to trim off that 50 thousandths off the top of the part. So I'm going to do a face toolpath. Go down to face. This is what I love about our CAM. It's always the same workflow. It's really easy to learn and easy to use because it's always the same. First we select our tool. Okay, I'm going to select the tool. I'm going to go and get a face because it knows we're doing a face operation. It filtered down on face operations. It knows what tools make sense for facing, but I'm going to filter even more to only use face mills that I'm using, that I'm working with. And down here I have different libraries where I have face mills. I'm going to grab, let's say, this 2-inch face mill. Say OK. It comes in, and that's a face mill that matches what I have in the machine. So I'm going to use that face mill. And my next thing would be selecting geometry, but when I did my setup, it knows, the CAM knows where the top of the part is, and it knows where the stock is. So I'm going to say OK, calculates, and we get a face toolpath taken at 50 thousandths off the top. We can take a look at it. I'm going to go up to Simulate. Okay, I can show it with my stock because it's actually building that stock from the body that I actually used and designed in our design workspace. And there it is, trimming off that top. There it is facing it. I think I have this thing set to loop. Let me right click and I have it looping. There we go. Let me close that out. So I was able to see it do the face mill. Now what I want to do is I want to adaptive clear the rest of it out. So our adaptive clearing, really great, efficient algorithm, toolpath that keeps the tool engaged as much as possible with the material, doesn't gouge the part, and it keeps it engaged and you're using as much of that flute length as possible in your toolpath. Really efficient way to go. So I'm going to select adaptive clearing, the same workflow. Remember the last tool we're working with. I'm going to select a 3/8, let's say a bull nose. Now I'm going to get a 3/8 flat mill. That's what I have in the machine, 3/8 flat mill to rough it out. Select it. There it is. The next step is, what's the geometry? Really, the geometry in a 3D toolpath is really about boundaries. It's about selecting the areas where you don't want the tool to go. It's really about making those areas, the containment areas where you want to keep the tool contained. In this case, I want the tool to go everywhere it can efficiently, so I'm just going to say OK. It'll calculate, look at my model, it'll look at the places on the model where it can go really efficiently to remove those chips. It looks pretty good. It's working its way down that Venturi, clearing out those pockets in those areas. See here, it's helixing down into the pocket. And when it reaches the bottom of the pocket, it starts working its way out, keeping a constant load on the tool and on the material, removing the same size chips. We could take a closer look if we do a simulation. So I go to Setup, Simulate, Play. We've already seen it do the face, and now we'd like to see it do from the outside in using a lot of that flute length, keeping the tool engaged with the material as much as possible. I'm going to fast forward it as it works its way from the outside in, and then it starts to work in that pocket in the center. Now again, works its way down, and I have it set as a tapered helix to help pull those chips out so you're not recutting those chips. When it reaches, I'm actually slowing it down here, but I could speed it up a little bit. In fact, I can even hide, make it transparent, and even hold, shall I say hide where the holder is. And as it works its way out, it keeps the same chip load, the same load on the tool, and the same size chip being pulled out. By being able to do this and control that optimal load, you can run at higher spindle speeds. You're going to transfer the heat from the tool into the chip that's getting pulled out. So you're able to run more efficiently, and you're keeping the same load, so you're not having those load spikes on the tool, which makes it wear out a lot quicker. So, and the places where it can't keep the same load, it backs out, lifts off the material, and comes into that corner, keeping that same exact load the entire time. So it's going to greatly reduce if it doesn't eliminate any of those corners where you would bury the tool. Keeping that same engagement, running at higher speeds, you can run at higher speeds and feeds. You're going to save your tool length, or shall I say save your tool life, and you're going to get the parts off the machine a lot quicker. Really efficient tool pass, the adaptive clearing. Great for clearing a lot of material out of those areas. And here it walks up those little walls. See where we left the taper? It's walking its way up, leaving that constant material, so when you come back to clean it up, it's always going to be a constant load. All right, we could fast forward through. It's going to, again, step down like a pyramid. Even though this is pretty much a prismatic part, it's going to look at the part, look at the faces and the surfaces of the model, and really apply that toolpath really efficiently to remove those chips. So I can hide some of the toolpath here so you can see what's going on. We can even see it as transparent. But there it's walking up the walls of our little Venturi, our little loft there, but it removed those chips really efficiently. Okay, we're going to come back and clean that up with a ball mill. I'm going to close that out. So now I'd like to be able to get these slots real quick while we're here, keeping the same tool. So I'm going to go up to 2D, slot. Okay, I'm going to choose the same tool as fine, 3/8 flat mill. For my geometry, I'm going to select these slots. Just simply select the edge of the slots right here. And then I'm going to select where I want it to start. Because we removed all that material, I don't want it to start from the top. I want it to start, I'm going to go to selection, at the top of the part where we left material. But I still want it to retract above the stock, but I only want it to start where there's material left. I'm going to say OK, and now the slot toolpath will now work its way down efficiently back and forth, even though the diameter is the same diameter as the slot, work its way back and forth to clear that slot out really efficiently. Okay, we want to get those drills real quick, so I'm going to go up to drill toolpath. I think those are 1/4 inch holes. If I hover over, yep, I get feedback. They are 1/4 inch holes. Okay, so I'm going to choose a 1/4 inch drill. Filters knows I'm doing a drill. It filters on different drills that make sense. So I'm going to look for a 1/4 inch drill that I work with. Even out of the sample library, we can do that. I also create a library for my aluminum tools. So if I look down close to the bottom, we could even filter even more. And I could choose which libraries I want to choose tools from, but I can also do like my local, these are my, my aluminum tools. I can get a 1/4 inch drill here, 1 1/4 inch. So it's really easy to be able to filter down. And another way, you notice I'm seeing all these drills and I'm like, man, I got to go all through that. I can filter on dimension and say I only want to see 1/4 inch drills. And now it filters down. Now I'm only seeing those 1/4 inch drills that I want to work with. Really quick and easy to do. So I'm going to select that 1/4 inch drill. I can see it in my graphics view. And I'm just going to simply select the holes, like that whole face. All I did was select the shaft of the hole. And if you have 80 holes on a plate, and you're thinking, man, I got to select every one of those, that can get really tedious. Well, what you do is you select the same diameter. Automatically grabs all those holes that are the same diameter. For our heights, we could tell it to drill the tip through the bottom. If you want to make sure that if you have like a countersink on the bottom of the hole, you can say I want to drill the tip through the bottom, and you can give it, a 1/16 of an inch or something through the bottom of the hole. Okay, just to show you real quick, we do have heights. We do have our cycles that work really well. We work a lot with Haas machines, and a lot of these cycles give you the code at the end directly. Okay, but I'm going to leave it as a regular cycle, and I'd like to clean up now. I want to clean up the faces and then the venturi. So I'm going to do a horizontal, a 3D horizontal, and I'm going to use that same 3/8 flat mill. Okay, let me cancel out of here. I think I still have it there. 3/8 flat end mill. And I'm going to say OK, because the horizontal will find all those places that are flat on the part that we need to clean up. So the horizontal finds its own containment. And we can also do the same thing with the contour to clean up on the outside. So if I did a 3D contour, I'm going to keep the same tool, my geometry. I can tell it an area where I want to bound it. I can also add some offset to that boundary and say OK. And what it'll do, it'll find all those places where we left on our walls to clean up, and it'll clean them up. Now I want to come in and clean this up with a ball mill. So I'm going to do a 3D ramp. 3D ramp will keep the tool engaged in that whole inventory area at a constant engagement. So what I want to do is I want to choose a tool that makes sense. So I'm going to use a 1/4 inch ball mill for this one. I want to make sure I have enough length there to get down to the bottom. Okay, so I want to check and make sure I have a ball mill. And if it doesn't, it'll show me. Okay, my geometry, I want to make sure that it stays inside of this bounding box right here. And then at my heights, I can also say, I want it to stay where my top height's going to be. I want it to be this edge right here. That's going to be the top. And I can also say, I don't want to go down too far past that bottom. And that's fine. Model bottom will work. Okay, and my passes, I can tell what's my maximum step down. Okay, and you can also change this according to the what you're trying to leave as far as cusps, and remove those cusps. Okay, so I'm going to say OK and see what we get. Starting with the ramp, working its way down to the bottom of the model. I probably want to go a little bit past, so I can add, if I right-click, edit, and I go to my heights, I can add a -0.02, something like that. Yeah, we'll go 20 thousandths below. Calculates, and now inside of that pocket, it's going to go 20 thousandths below. So I have a nice smooth transition there. So I did a ramp, but there's many different toolpaths to be able to do that with. Okay, so let's take a look at all that we have. So I'm going to highlight Setup, simulate what we have. I can also fast forward through like this. We've already seen it do that one. There it's doing the slots. We can take a look at what those slots look like as it's machining them. Speed it up a little bit, doing those slots. Okay, drilling those holes, and now it's roughing, that's doing the horizontal. Okay, now we're doing the cleanup with the contour, and it's trying to clean up there the best it can. And now we're doing our, right down here you can see we're doing our ramp. And that's ramping its way down. Now you can see where it's hitting a little bit of those corners there. It should clean up pretty nice, and I probably would do a little bit more of a fine cleanup after this to get rid of some of those cusps. But it's really about how fine do you want that to look. You can rough it, come back, and then get a nice fine cleanup after those cusps there. Clean up those cusps in the corner. But that's a ramp, and you could try different toolpaths, but that'll rough it out, or at least that'll get it finished. But I would really dial in to get those cusps really low. So that's being able to get some of the 3D toolpaths onto the part. And if I bring up, so we were able to walk through, I drew up a part from scratch, walk through that. We're able to download, upload, and be able to make an assembly out of a part, SolidWorks part. We're able to apply some joints to be able to assemble these things and make it a sliding jaw or moving jaw. We're able to bring a part in from our data panel, that part we created, set it up. For going into CAM to get some toolpaths on it, we're able to do a setup on the part using the solid model we created as our stock, able to get some toolpaths on there really quickly to rough it out. Now let's post the code to our machine. So while I have setup highlighted, I'm going to go up to, let's get some, actually before I do that, I want to get a setup sheet. So I could save it. I can choose if I want the setup sheet or the project data, NC data, to be saved in a local file, or I can also save it in a project file inside of A360. You can set this up through your preferences, and you can share that data with each other and with your associates that you're working with. But in this case, I'm going to save it in this local folder that I have. I'm going to select that folder, and now I have a setup sheet right out of the box. There's my WCS. That's where I want to set it up in the machine. If I set my assembly up correctly, I could just plug those numbers. I can see a graphics view of where my origin is. And down here, I have the totals for each operations, which tools we're using, maximum spindle speed, my cutting distance. There's my maximum feed rate, the time it's going to take for the whole program. Each setup for each operation has the tool, the holder, the length offset, diameter offset, the time it's going to take for each of those operations. Really good setup sheet right out of the box. Now let's get some code to the machine. So I'm going to go and post out. So if I highlight setup, go up here to post process. Okay, this is our post interface. We have lots of posts that come with come just generic with our software. Tons of them in here. And I work with Haas a lot, so the Haas Haas generic works really well with the VF machines and the TM machines. And down here we have some settings that we can put, whether we want to have, use helical moves, high feed mapping. I can change my high feed rate right here. If it's going too fast and my machine can handle, I can plug that in. Down here, if you want to preload the tool while your carousel's coming around with the next tool. Down here you can use G28 versus your G54. You can turn these on. Radius, R versus IJK. So you have all these different switches that you can choose, the tool list on top of the code. And if you don't see your post in here, I recommend going in here. You could search for our online post library, and you could do a search in here. You could search by vendor, machine tool dealer, by the time, but by the date. You can search if it's a mill turn. I'm sorry, by the type. If it's a milling, turning, mill turn, you can filter on a lot of the different posts that we have. A lot of these are the generic. If you need specific post help, I recommend going through our forum. If I go down here to our main forum, there we go. There's our main HSM forum, and you also can go through our Fusion forum. But if you go through our main HSM, and there's our support forum, and there's also a post-processor forum. If you go through the post-processor forum, you can do a search. We have our users, our elite users in here that check every day and work with posts. This is a great place to start. Do a search for your machine and your post, and I'm sure you'll find some feedback. And if you're not sure and you have questions on working with your post, it's a great place to learn how to work with JavaScript, how to get an editor for post-processing, getting started. This is a great place to start. There's Post Processors 101. This is ground zero to get started with your post. But I suggest do a search in here, take a look, ask questions to our elite users who are in here, but this would be your first place to look for post-processor help. We have a lot of resellers that are in here to work with posts, so keep this in mind. So it's here at our HSM Post Processor forum at forums.autodesk.com. Great place to start. So I'm going to post out this code using my generic Haas. I'm going to go to post. Save it there is okay. You can probably change it. I already have a 1001 program since I do this often. And now I got some code that I can save on my thumb drive and bring it right over to the machine and start machining this part. So that quick, I know we went over a good bit, but hopefully it was good information for you. There was a lot we covered. And I like to cover a lot, but hopefully it was helpful. We're getting from that raw part to be able to get code. That's what it's really about, is using this tool, how easy it is to work through. We can see it's always the same workflow, right? We have good 3D toolpaths that can really clean up and get your part looking nice, and it's quick to be able to draw up a part. You don't have to do the whole step of making an assembly, but I like the idea of matching what's in the machine, so I wanted to show you how to do that. but you can always get code on just the part alone. Okay, so I talked a lot. Hopefully it was helpful for you. Please check in every week. We do these. We do our Kickstart, or we call them the Fast Track to CNC Programming. We do them every Wednesday. And every Friday, we have a technical HSM hangout where we have our expert elites that join us to walk through tips and tricks and how to set up machines. We had John Saunders from NYC CNC last week join us and gave us a great overview of what he went through, his story, starting with a machine in his apartment, working all the way up to having a full running shop with Haas machines, and it's just amazing stories, and the tips that they give us and the advice is priceless. Please join us every Friday, and this Friday we're going to have Angelo Juras. He is a master machinist working out of Pier 9. He's going to be here to help us this Friday to walk through some great work holding tips. So I highly recommend joining our Friday webinars. We have them every Friday, and every Wednesday is our Fast Track webinars. So please join us, and we'll be here next week. So with that, thank you everybody.